All right, let's prove this theorem that says for all x and y in the real numbers, the absolute value of x times y is equal to the absolute value of x times the absolute value of y. So for this, we have three cases to consider. So for the first case, we're going to assume that both x and y are greater than or equal to 0. In that case, x times y must also be greater than or equal to 0. And when you have a positive number, when you take the absolute value, it's just going to stay itself. So the absolute value of xy is just going to be equal to xy. But notice that the absolute value of x is x, and the absolute value of y is y, since they're both positive. So we can say that this is equal to the absolute value of x times the absolute value of y. So we've shown it for the case where they're both positive. Now let's consider the case where one is positive and one is negative. So let's say x is positive and y is negative. Then in this case, we're going to have that xy is actually going to be less than or equal to 0. Now, from the definition of an absolute value, if we take the absolute value of a negative number, then that's the negative of what we plug in. So the absolute value of xy then is going to be equal to negative xy, because this would make a negative number positive if we negate it. Now notice that this is the same thing as x times negative y. And then for the same reasoning as what we had to get to this step, we also have that the absolute value of x is going to just be x. So we know that this is going to be the absolute value of x. But the absolute value of y, since it's negative, is going to equal negative y. So this is going to be the same thing. So we get the same result. And then for the last case, let's say that we have both of them less than or equal to 0. In this case, we can say that xy is going to be greater than or equal to 0. So the absolute value of xy is just going to equal xy. But notice this is the same thing as negative x times negative y. And this is actually the absolute value of x and the absolute value of y, respectively. So this is still the exact same result. So we've proved it for all three cases, and we have that the theorem is true.